This will be continuation of previous class, that is class number 4.5. In the previous class, we were solving one problem on this roller type of a follower. Yeah. So this was the problem which was discussed in the previous class. So you can see this is a roller type of a command follower, and these are the four angles, that is outward stroke with the 150-degree dwell for the next 30-degree, written for the next 120, and dwell for the remaining period, that is the nothing but 60-degree. So these are the given things, and I have noted down all these things. So once again, you can go through these given data, that is a stroke length, which is given as a 3 centimeter, the base circle radius, which is also given as a 3 centimeter, and the roller diameter is given as 1.5. I want the roller radius, I'll take it as a 1.5 divided by 2. It means the roller radius will be 0.75 centimeters. And you can see the speed of the cam is given as the 300 RPM, which is in clockwise direction. And these are the four angles. And the outstroke angle is 150 with a uniform acceleration and a retardation motion. And the return stroke is having an angle of 120-degree, and it is with simple harmonic motion. And it is given the offset by 1 centimeter towards right. So I'll take the offset circle radius as 1 centimeter. And one more important parameter for this kind of a roller type of a follower is this prime circle radius. So this will be helpful while drawing the cam profile, both for a radial follower as well as offset follower. So this prime circle radius is nothing but the summation of a base circle radius, that is 3 centimeters. You can see here, and the roller radius, that is 0.75. So it becomes 3.75 centimeters. So just just make a note of this prime circle radius. With respect to this circle as a reference only, I'm going to draw the cam profile. And after that, we have gone through different formulas which are required for this problem, and we found the maximum velocity and acceleration during outstroke, which is with the UARM, and similarly the maximum velocity and acceleration during the return stroke, which is with the simple harmonic motion. And we got all these answers. After that, we have started with a displacement diagram, and these were the steps. Just you can see, first we have indicated all the four angles, that is outstroke angle, dwell angle, return stroke angle, and the second well angle along the x-axis. And along the y-axis, I have taken the stroke length, and I have divided this outstroke into 6 equal parts. Total is 7.5. It means each division will be 1.25. After that, I have followed what are the steps which are required for drawing the displacement diagram with respect to this uniform acceleration and the retardation motion. And I got this displacement diagram. Yeah, I got this curve, that red color curve. It is nothing but the displacement curve for uniform acceleration and retardation motion of the follower. After that, similarly, we got the displacement diagram for this return stroke also, so which is with a simple harmonic motion. That's why we have used this semicircle method, and we got this continuation of this displacement diagram. So you can see the blue color line. This is a complete displacement diagram for both the outstroke and return stroke for a different type of follower motion. After this, after drawing all these displacement diagrams, let's get started with this cam profile. Okay, so this is the cam profile which is required. So first case, I'll go with the radial follower, that is a cam profile for radial follower, which is also specified as the follower axis passes through the cam axis. Okay, let's get started with this cam profile in this today's class. So this is the cam profile which is highlighted with the red color. I want this cam profile for the given data. That the data may be the angles, the data might be in terms of a radius, the base circle radius, and the prime circle radius. So I'll explain this cam profile, how to draw this cam profile step by step. And then these are the steps. After that, you can go through these steps. I'm going to follow these steps to construct a cam profile for radial follower. After the class, you can go through all these steps. So first I'll locate the center, that is alphabet O. After that, I'll draw a base circle with a radius of 3 centimeter, which is given in the problem. And I'll indicate the axis which is passing through the center of the circle. So this is the vertical axis, which is passing through this circle. Yeah. After drawing this, there is one more extra circle, that is a prime circle. This comes only picture in the type of a roller type of a follower. Remember this prime circle. You have to use this only in the case of a roller type of a follower, not for the knife edge, not for the flat faced follower. So I'll revise once again. First, I have drawn this base circle with 3 centimeters, and after that, I have indicated the vertical axis of this circle, which is passing through the center of the circle at alphabet O, at center O. After that, I have drawn a prime circle radius, that is a 3.75 centimeter. So already I have explained what is exactly this prime circle radius. It is a summation of the base circle radius, that is a 3 centimeter, plus the roller radius. Okay, the roller radius is 0.75 centimeter. The total, I'll get the prime circle radius as 3.75. And after that, as you can see, this vertical axis will intersect this prime circle at this point. I'll name this point as capital A, right? And after that, I'll draw the roller. I have to indicate the roller follower. First, I'll indicate the roller with a radius of 0.75 centimeter, which is given in the problem. The diameter is given, that is 1.5. I want the radius, it will become 0.75. Just take the center as this point A and just draw a circle. With the help of compass, just take the radius as the 0.75 centimeter and take the center as alphabet A, just draw the circle. So which indicates the roller follower. And you can give the height of this follower as 3 centimeter. So because the stroke length of the follower is 3 centimeter, so you can take approximate of 3 centimeter. So I have indicated, so far I have indicated this base circle with a radius of 3 centimeter. After that, I have indicated this prime circle with a radius of 3.75, and I have located the axis of this base circle as well as prime circle, and this axis will intersect the prime circle at point A. And after that, at point A, I have drawn this roller because I need to indicate this follower. So I have taken the center as A with a radius of 0.75 centimeter. I have drawn this roller and I have indicated this follower. After this, I'll join this point O to point A like this. I'll take this as a reference. So this is the starting point. And
Sir, once again tell the followers height.
Okay. So first base circle comes, then prime circle with a radius of 3.75, and you can see this axis of this base circle or the prime circle, which is passing through this center of the circle. So this axis will intersect the prime circle, not the base circle. As I said, just give the importance to this prime sickle, not the base sickle. Just forget about this base sickle. It is not useful for this roller type of a follower. Okay, only concentrate on this prime sickle. So it means the red color one. The red color circle is nothing but the prime sickle. This prime circle and this vertical axis, which is passing through this center of the circle, will intersect at this point. So you can see. So this is the intersection between the vertical axis and the prime circle. So this intersection, I'll name it as alphabet A. Okay, alphabet A. And at this point, using the compass or the rounder, I'll take the radius as 0.75. I'll take the radius as 0.75, and with the center as point A, I'll draw one circle. I'll draw one circle. Okay, and this circle will be tangent to this base circle. Don't worry about that one, because I have taken the prime circle as base circle radius plus roller radius. So this is 3 centimeter. So this much 3 centimeter, and the roller radius is 0.75. Total 3.75. So that's why exactly this roller circle is tangent to this base circle. Don't worry too much about that one. Only just take the center as this point A and the radius as 0.75. Just draw one circle. Okay. After that, just indicate the follower with a height of 4 centimeter. You can take any length. For your convenient, you can take 4 centimeter. This height. So you can take of any length. Okay. Yeah. So from this point, you can take 4 centimeter, or you can start from this also. Don't worry about that one. Just indicate it is a follower. Okay, it is a roller type of a follower. After that, I'll join this point O and point A. So this is the reference line. This is the reference line which is required to indicate all the 4 angles. Okay. And one more thing, I'll confirm whether the cam is rotating in clockwise or in anti-clockwise direction. So, and it is given in the problem, the cam is rotating in clockwise direction. That's why I'll indicate all the 4 angles in a counterclockwise direction like this. If it is in the problem, it is given as the counterclockwise, the cam rotation is in counterclockwise like this. You have to indicate all the angles in clockwise like this, towards your right side, 150, 30, 120, and 60. But in this case, the cam is in clockwise, so I'll indicate all the angles in a counterclockwise direction. It means I'll take the direction. You can see the green color. So this will be the direction for indicating all angles, which is in counterclockwise. And what I'll do after that, I'll keep the protractor over this vertical line, such a way that the 0 degree of the protractor will be in line with this reference line OA. It means your protractor will be facing towards your left side like this. And the center of that, the base of the protractor, the center of the base of the protractor will be here, approximately here. Okay. And after this, I'll indicate the first angle, that is 150 degree, that is AOB. So you can see. So this is the first angle, AOB. Okay. And one more thing is, just you have to ignore this base circle. Don't worry about this base circle. Only concentrate on this prime circle, which is highlighted with a red color. And I'll indicate the alphabet B on this prime circle only, not on this base circle. That is the only difference with respect to the knife edge follower and with respect to this roller type of a follower. And after this, the next angle is 30 degree. So again, I'll take this as a reference line. Again, I'll take this as a reference line. I'll indicate the 30 degree like this. So this will be BOC, the second angle, the dwell angle. And also again, I'll indicate the alphabet C on this prime circle only, the red color circle. And the next angle is 120, the written stroke angle. That is COD. It is nothing but 120 in a counterclockwise direction. Again, I'll indicate the alphabet with respect to the prime circle. And the last angle will be DOA, which will be 60. Okay, so these are the four angles I have indicated, and I have taken the reference as this prime circle. Okay, and after this, I have to divide this outstroke angle and the written stroke angle into 6 equal parts. I'll not worry about this angle BOC, the dwell angle, the first dwell angle, and DOA, the second dwell angle. I'll not worry about these dwell angles. I'll divide only the outstroke angle and the written stroke angle. Yeah. Just wait for a second. Yeah. And the next step is dividing the outstroke and the written stroke angle. And you can see the outstroke angle is 150. I want 6 equal parts. How much it is? Anyone? 150 by 6?
25.
25, correct. 25. Yeah. And I'll divide the prime circle. So you can see here. So this is a 25, 25, 25, 25, 25, and 25. And you can see I have indicated all these points, that is 1, 2, 3, 4, 5, 6, on this prime circle only. But as in case of a knife edge follower, you are indicating the numbers 1, 2, 3, 4, 5, 6 on the base circle. That is the only difference. Remember, okay? Because I want the center of these circles, because I need to construct these centers. Okay? But in case of a knife edge follower, directly the edge of the follower is in contact with the base circle. Correct? But in this case, the roller is in contact with this base circle, and I want the reference as the center of this roller. That's why to construct all these circles, I want the center of the circles. That's why I'll indicate all these divisions 1, 2, 3, 4, 5, 6 with respect to this prime circle only. That is the only difference, and just make a note of that. And each angle is 25, 25, 25, 25, and 25. And you can call these as the radial lines. Radial lines which are joining from these 6 points to the center of the circle. Center of the circle. And after that, what is the next step? Just extend all these blue color lines to some distance, to some convenient distance. Okay. And the next step is you need to transfer the distances from the displacement diagram. That is 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, and 6 to 6 dash. If you want, I can show that one. Yeah. So I want to transfer all these 6 vertical distances. That is 1 to 1 dash. I'll measure with the help of compass, and I'll draw the arc in the cam profile. Again, I'll copy this 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, and 6 to 6 dash with respect to the outstroke, because I'm constructing the cam profile for first this outstroke. Later onwards, I'll copy these distance also when I'll be constructing the cam profile for the written stroke. Okay. Now, using the compass, I'll copy all these 6 vertical distance one by one, and I'll go to the cam profile. Okay, and I'll take the reference first. I'll take the reference as 0.1. I'll take the reference as 0.1. I'll draw one arc here. Okay. Similarly, I'll copy the distance, that is 2 to 2 dash, from displacement diagram. Again, I'll draw the arc. Again, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, and 6 to 6 dash. So these are the intersection points with respect to these radial lines. And I'll give the naming as 1 dash, 2 dash, 3 dash, up to 6 dash.
Sir, from prime circle, no?
Yeah.
Distance.
From prime circle.
Distance from the.
Correct. Because these 1, 2, 3, 4, 5, 6 points are present on this prime circle only. The reference is this only, the prime circle. Point 1, 2, 3, 4, 5, 6. Just ignore this base circle. Don't worry about this base circle. Okay. Is that clear?
Yes, sir. Clear.
Okay. And after getting all these 6 points, just draw the curve. Before that, there's one more step. One more change says at all these 6 points, that is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, before drawing the cam profile, you have to draw the circle with a radius of this 0.75. So like this. Just take the center as 1 dash. Just take the center as 1 dash. Just draw one circle with a radius of 0.75. And take the center as a 2 dash. Just draw one more circle. Similarly, 3 dash, 4 dash, 5 dash, and 6 dash. This is the only change, because the reference is with respect to the center of this roller, not the end of this roller. Okay, that is the only difference with respect to the knife edge follower. And after drawing all these circles at these 6 points, that is 1, 2, 1 dash, 2 dash, 3 dash, 6 dash, starting from this point, it means the point on this base circle, is draw tangent to all these circles. I'll show the tangent how it is. Yeah. Just start from this base circle, the end of this roller. Okay, or the intersection between this roller and this base circle. This is the first point, starting point. Just draw tangent to all these rollers. Just draw a smooth curve such a way that this cam profile will be tangent to all these roller circles. That is the only change. And this is the cam profile for only the outstroke angle, that is for 150. Correct? And in a similar manner, I will go to this return stroke angle, that is a COD, that is 120. Again, I'll divide this 120 into 6 equal parts, that is 120 by 6.
20 degrees.
20 degree each, right? Correct. So I'll indicate 20, 20, 20, 20, 20 on this prime circle only. So you can see the points, all these points are present on the prime circle only. Yeah. And you can see these are the numbers 6, 5, 4, 3, 2, 1, 0. I'll give the number in reverse order because the follower will be coming down during this angle, that is the return stroke angle. And I'll draw the radial lines passing through all these 6 points like this. So you can see these green color lines. These are nothing but radial lines which are starting from this center of the circle and passing through all these 6 points. Similar to this outstroke angle. So same method. And after that, I'll extend these radial lines in a downward direction to some convenient distance of any distance. Okay. And the next step is again with respect to these 6 radial lines, you have to transfer the distances from the displacement diagram. That is 6 to 6 dash, 5 to 5 dash, 4 to 4 dash, 3 to 3 dash, up to 1 to 1 dash. Again, what I will do, I'll go to the displacement diagram. This one. And with respect to this return stroke angle, this one, return stroke angle, I need to indicate all these 6 vertical distance. That is 6 to 6 dash, 5 to 5 dash, 4 to 4 dash, up to 1 to 1 dash. I'll copy all these 6 vertical distance one by one with the help of compass. And again, I'll go to the cam profile. And I'll take the reference as a 0.6. I'll draw an arc. This arc will intersect this radial line, this green color radial line is passing through this 0.6 at this point. This is the first intersection point. I'll indicate as a 6 dash. Similarly, I'll copy a 5 to 5 dash from the displacement diagram. Using the compass, I'll draw one more arc by taking the reference as this prime circle only. The points which are present on this prime circle only. That is 5. I'll get 5 dash. Similarly, 4 to 4 dash up to 1 to 1 dash. So if you want, you can read the instruction which is given at the left side of the screen. Okay. And after that, again the same step. Draw a roller at these 6 points. Just take the center as a 6 dash. Just draw one roller with a radius of 0.75 centimeter. Because similar to this outstroke angle. So you'll get 6 circles or 7 circle, including this also, at these 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash. Okay. I'll draw one more circle at this point also because I need to end this cam profile on this base circle. Now again I'll continue this curve, this black color cam profile, in such a way that the curve will be tangent to these circles also, these pink color circles, like this. You can see the black color curve which is started from this base circle and it is tangent to all these circles, that is these circles pass with respect to the 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, again 6 dash, 5 dash, 4 dash up to 1 dash and this 0. So the curve will be tangent to all these rollers. Okay, and I'll complete this cam profile up to this. Starting point is this. Again, the end point has to be the same point. Just indicate one more line. Okay, on this base circle. So this is the cam profile, and these are the namings. This is the cam profile. So this is a base circle with a radius of 3 centimeter, and the red color is nothing but the prime circle, that is with a radius of 3.75, and this is a roller with a radius of 0.75 centimeter. So this is the complete cam profile for this case. It means the follower axis passes through the cam axis. Please take 30-second time. If any doubts in this cam profile, please let me know so that I can explain once again. And if it is clear, I'll go to the second case. If you want, you can see the steps once again for your convenience. Yeah, this was a basic radius with a radius of 3 centimeters. The axis passing through this base circle, then the prime circle with the 3.75, and I'll indicate the point A on this prime circle where there is the intersection between this vertical axis. I'll draw the roller with a radius of 0.75 centimeters. I'll indicate the follower with a height of 4 centimeters, or sorry, 3 centimeters, because the stroke length is 3 centimeters.
So from where to where 3 centimeter? From prime circle?
Yeah, you can take the center as this one only. From this point A itself. It will not matter. It will not matter.
From that point 3 centimeter, no?
Yeah. From this point A, just take a 3 centimeter height.
Okay, sir.
Okay. After this, I'll join A to O. And this is the direction of cam rotation. It is in clockwise. I'll indicate all the angles in a counterclockwise opposite to this one. That is a cam rotation. This is the reference line. The first angle is 150. Second is 30. And the next is 120. And next is 60. And you can see I have indicated all these alphabets A, O, B, B, O, C, C, O, D on this prime circle only. And I have divided this outstroke into 6 equal parts, that is 150 by 6, that is 25 on the prime circle only. Is the next step. Then these are the 6 divisions. Extend them and transfer the distances from the displacement diagram corresponding to the outstroke angle. We'll get 6 more points, 1 dash, 2 dash, 3 dash, 4 dash on these radial lines. And the reference is again the point 1, 2, 3, 4, 5, 6 with respect to the prime circle only, not the base circle. And I'll draw the rollers by taking the center as 1 dash, 2 dash up to 6 dash, the radius of 0.75 centimeter. And starting from this point, the point between the roller and the base circle, I'll draw the tangent to all these roller circles, so which is highlighted with a black color. And in the similar manner, I'll follow the same step. I'll divide this written stroke into 6 equal parts, that is a 20 degree each, with respect to the circumference of this prime circle only, not the base circle. I got these 6 points. I'll draw the radial lines. I'll extend them to some convenient distance. Again, I'll transfer the distances from the displacement diagram corresponding to the written stroke angle. I'll get these 6 points from 6 dash to 1 dash. I'll draw the circle with a radius of 0.75. Again, I'll continue this cam profile in such a way that it will be tangent to all these circles like this. And this is the final cam profile, the black color one. Again, just continue this curve and end at this point. Okay. And if it is clear, I'll go to the next one, that is for the second case, that is a offset type of a cam and follower. It is given the follower axis is offset by 1 centimeter to right. Okay. Again, the steps remain same. Only you need to shift this follower towards your right, such a way that the axis of the follower and axis of this center of this cam, they are separated by 1 centimeter towards right. Only that is the difference, and you have to draw the tangent lines to this offset circle instead of drawing the radial lines. Instead of drawing these radial lines towards the center, you need to construct one more extra circle, that is the offset circle, and you need to draw the tangent. That is the only difference. And I'll explain this cam profile. Okay, and these are the steps you can read after the class.
So that offset circle radius is 1 centimeter, no?
1 centimeter, because it is given as the follower axis is offset by 1 centimeter. It means the offset circle will be 1 centimeter. Yeah. First, I'll start with the base circle. I'll take the center point as O. Again, I'll draw the base circle with a radius of 3 centimeters. And I'll indicate the vertical axis passing through the center of the circle. After that, again, I'll indicate this prime circle, the radius of 3.75 centimeters. And there is one more extra circle for this case only, for this second case, that is the offset type of follower. This circle will come extra, that is a offset circle with a radius of 1 centimeter, which is equal to the offset which is given in the problem. You can see, draw the offset circle by radius 1 centimeter. After that, just indicate a horizontal line with respect to this center of this offset circle, because I want to indicate the axis of the follower. So that's why I'm going to draw a tangent to this offset circle, that is a green color circle. So you can see this is the tangent, the vertical tangent. You can see this, the dotted line is nothing but the axis of the cam, and this line is nothing but the axis of the follower. So this is the axis of the cam, and this is the axis of the follower. And you can see they are separated by 1 centimeter because you have taken the radius as 1 centimeter. That's why you get offset by 1 centimeter. And at this point, you can see this follower axis. It will intersect the prime circle at this point. I'll take this point as A. So this point. So in the previous case, in the first case, I have taken this point as A because the axis of both the follower and the cam they were same. But in this case, the follower is shifted towards right. That's why I'll indicate the intersection between this follower axis and the prime circle at this point as a point A. So this is point A. Okay. After that, you can indicate the roller with the radius of 0.75 by taking the center as a point A. Okay, this is a roller with a radius of 0.75 and the center is again A. Similar to the previous one. The previous case, this circle was at this point. Okay, since it is an offset type of a follower, there is a slight offset towards your right. So if in the problem it is given offset towards left, again you have to draw a horizontal line like this and you have to draw the tangent to this offset circle towards your left. Okay, in that case you'll get the circle here. Okay, exactly the mirror of this one, mirror of this drawing. Okay, I'll not worry about that because in this case the offset is towards right, so that's why I'll indicate the follower towards right. And after this I'll indicate this follower with a height of 3 centimeters from this point A only. Okay, just indicate the height of this follower as 3 centimeter. If you take more than this 3 centimeter, that is also fine. Don't worry about that much because I want only the cam profile. And after that, just join this center of the circle and this point A, the blue color line. Blue color line. So this is my reference line, 0 to O, 0 to A. And again, I'll check the direction of the cam profile. That is a cam, that is clockwise. I'll indicate all the 4 angles in counterclockwise, opposite to this cam rotation. So you can see the direction is in counterclockwise. It's nothing but the indication of angle has to be opposite to this cam rotation. Again, I'll keep the protractor over here. That is a blue color line, OA. The 0 degree of protractor has to be in line with this OA line. I'll indicate the first angle, that is 150. It is AOB. And I'll indicate all the alphabets on this prime circle only. AOB. The second angle is again 30. BOC. Next angle is 120. COD. And the last one is a 60. That is DOA. Now all these alphabets are with respect to the prime circle only. And again, I'll concentrate on this outstroke angle, that is 150, and the written stroke angle, 120. I'll not worry about these two dual angles. After this, again follow the same steps. I'll divide this outstroke angle, that is AOB, that is 150, into 6 equal parts. 150 by 6, again 25. Okay, let's take the reference as AOB, between point A and point B. Between point A and point B, just divide this prime circle into 6 equal parts. Okay, between point A and point B, the total angle covered is 150. 150 by 6 is 25 each. You can see the blue color points. You have to indicate on the prime circle only, not the base circle. And just give the number, that is a 0, 1, 2, 3, 4, 5, 6. You can indicate 0 here also, no problem. If you want, you can zoom this area for your convenience. Okay, so you can see 1, 2, 3, 4, 5, 6 are with respect to the prime circle only. If you want, you can indicate this O here itself. And the only change is, instead of drawing the radial lines through the center, you have to draw the tangent to this offset circle passing through point 1. Just draw one tangent to this offset circle from point 1. Similarly from point 2, 3, 4, 5, 6. You can see the blue color lines, so which are started from these 6 points, 1, 2, 3, 4, 5, 6 on the prime circle, and you can see these are tangent to this offset circle, which is highlighted with the green color. So this is the first tangent, second tangent, third, fourth, fifth, and sixth. Okay. So this is the only difference. If it is a radial follower, you have to draw the radial lines. If it is offset follower, you have to draw the tangent lines. Remember the keyword, the tangent lines, not the radial. Radial means you have to join all these 6 points to the center of this circle. Okay. And here it is radial lines. It means all these lines are tangent to this offset circle. And what is the next step? You just extend all these tangent lines in a backward direction, like this. Again, go to the displacement diagram. Just take the reference as 1, 2, 3, 4, 5, 6. Copy the displacement distances with respect to the outstroke. Just draw the arcs. 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, and 6 to 6 dash. Okay, I'll get these distances on these radial lines, these tangent lines, from the displacement diagram. So use the same method whatever you have followed for the first case. Using the compass, I'll get all these 6 vertical distances from the displacement diagram corresponding to the outstroke angle. And I'll transfer on these tangent lines, and I'll get these 6 intersection points on these tangent lines, that is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Again, just take the center as these 6 points, that is 1 dash, 2 dash, up to 6 dash. Just draw the roller because I need to indicate this roller. The reference as 1 dash, I'll draw a roller with a radius of 0.75. Again, the center has 2 dash, one more roller, 3 dash, one more, up to 6 dash. Again, just draw a tangent to all these circles, starting from this first circle. From this point you can take, okay, just draw a tangent. Just draw a freehand curve which has to be tangent to all these pink color circles, which are nothing but roller circles. Okay, so this is the cam profile for this outstroke angle, that is 150. And in a similar manner, I'll divide this written stroke angle, that is a COD. I'll divide this circumference of this prime circle between point C and point D into 6 equal parts. The total angle covered is 120. 120 by 6 is 20 degree each. So I'll indicate all these divisions on this prime circle only, not the base circle. After that, I'll give the naming, that is 6543210. So this again, I'll start from here itself, 6543210. Again, with respect to these 6 points, I'll draw tangent to this offset circle. You can see these pink color tangent lines. You can see this is the first tangent line, which is starting from this point 6 from the prime circle, and it is tangent to this offset circle. And similarly, you'll get 6 tangent lines, or you can, including this also, you can get 7. And just extend these tangent lines in a downward direction, similar to the first case, this outstroke angle. And again, just go to the displacement diagram. Just copy the distances from the displacement diagram corresponding to the written stroke. Again, you have to copy all these 6 vertical distances from the displacement diagram. If you want, I can show that. Yeah. With respect to this written stroke angle, I need again the same distances from 6 to 6 dash up to 1 to 1 dash. Using the compass, I'll copy all these vertical distances one by one. Again, I'll go to the cam profile. By taking all these points on the prime circle as a reference point, I'll draw the arcs, that is the 6 to 6 dash, 5 to 5 dash, 4 to 4 dash on these pink color tangent lines. It's a tangent to this offset circle and passing through these 6 points. I'll get the intersection points, the blue color dots you can see here. I'll give the naming as 6 dash, 5 dash, 4 dash up to 1 dash. Again, just take the center as this 6 dash. Just draw a roller with a radius of 0.75. Again, one more roller at 5 dash, 4 dash up to 1 dash and this 0. And just continue this cam profile from this outstroke angle such a way that this curve will be tangent to these circles also, like this, and end this at the last circle. Okay, you can see. So this is a cam profile, which is nothing but a freehand curve which is tangent to all these circles. This black color one is nothing but the cam profile, and again end here. Just draw one more line here, one more curve at this point. So I have started from this first roller, and it is tangent to all these circles with respect to the outstroke and with respect to the return stroke, and again I'll end here itself. Okay, this is the cam profile.
It
You
is
can
not
see.
touching
Yeah,
one. It is not touching one. One
where,
roller one.
yeah, just make a correction. It has to touch. Just make a correction here. Okay, slightly do the modification. Okay, thank you for that correction. Just draw a curve, and it has to tangent to this roller which is passing through, which is taking the center as this 1 dash. Okay, just do the slight modification. It will be like this. Yeah, thank you. So this is the completion of a cam profile for offset follower, and you just indicate all the namings. That is a cam profile, a base circle with a radius of 3 centimeter, and the prime circle. This is a red color one, the radius of 3.75. Again, the roller as a 0.75, and this is the follower. And one more important thing, you have to indicate this offset distance between the follower axis and the center of the prime circle or the base circle. Yeah, so I think we have completed all the 3 drawings. That is a displacement drawing, and a cam profile for radial follower, then cam profile for offset follower. Okay, only the thing is you need to draw the cam profile such a way that it will be tangent to all these rollers. And one more thing is you need to take the reference as the prime circle only. It means you have to divide the outstroke angle and the return stroke angle on this prime circle only, not the base circle. Okay, this is the only difference when you compare with the knife edge follower. Okay, so if it is clear, I'll close today's class. Okay.